All right, hey y'all, let's cover 2.7. So this first part up here is direct, well, it's all from your book, but this part in particular, you need to make sure you have this pulled aside so that you're comfortable with setting up your interval notation, since that's what we're going to be focusing on. Okay. Some professors prefer to use set builder notation. If you move on to pre-calculus, Angela is one of those who prefers the set builder notation. So once you find out which one your professor prefers, just go with that. Honestly, I'm good with whatever you want to present, set builder, interval notation. Get comfortable with both, okay? Because you're going to have different professors. All right, so let's talk about using interval notation to express all real numbers greater than or equal to A. Use interval notation to indicate all real numbers greater than or equal to -2. Okay, so what does that look like? Well, let's start by looking at a number line. Let's go all basic. -2, -1, 0, 1. That's enough. Indicate all numbers greater than or equal to -2. Now, in my open math, you're going to either need to place a dot or a circle. A dot includes the number, so that's when you see the equal to portion, and a circle is just going to be referencing a greater than or less than without the equals. Okay, so in this case we have equal. So if I'm doing this on my open math, I would put a dot at the -2 position. All right, now from this dot, are we going to go to the left or to the right? Remember, the numbers get smaller to the left and larger to the right. So indicate all real numbers greater than. So greater than means we're heading right. Okay, so let's put this in interval notation. Because it's a negative, because it's a dot and not a circle, we're going to use a bracket, and the bracket goes in the direction that your arrow is going to be going. Okay, so your bracket's going to be facing this way, and it's going to have -2, and then it's heading towards positive infinity. And infinities always have the parentheses because we don't know the last number. All right, the bracket means that -2 is included in the set. All right. Use interval notation to express all real numbers less than or equal to, we're going to use a dot again, A or greater than equal to B. Write the interval expressing all real numbers less than or equal to -1 or greater than or equal to 1. Okay, let's do our line again. And we're talking about -1 to 1. So all real numbers less than or equal to. So less than is going to be going to the left. -1. And it has the equal to, so it gets a dot. And then it's less than, so the arrow is going to go to the left. Or greater than or equal to 1. We've got the equals again at 1, and they're saying greater than, so that takes off to the left. So what does this look like in interval notation? Well, we've got negative infinity, because going from left to right, just like you're reading a book, negative infinity to -1. -1 is included, or, and the reference for or is going to be like this, and then it's going to be from 1, oh, it should have a bracket, 1 to positive infinity, which gets a parenthesis. Okay. So you only put parentheses on negative and positive infinity, but the -1, I know that it's included because it has the bracket. Okay. Same thing for 1. I know it's included because it has the bracket, not parentheses. All right. And this is just a reference for or. If the other way, if you're going to be using this more often too, once you get past this class, is this is referencing and for me, I always think of it as I could always go and have an A. So if that helps you remember it, great. If not, find something that does. It's not the end of the world. All right, so let's demonstrate the addition property. This is just solving for x. Okay, nothing exciting happening in this first part. So for A, x minus 15 is less than 4. We're going to add 15 to both sides, and we get x is less than 19. It just says to illustrate it, but I'm going to go ahead and put it in interval notation for you. So if x is less than 19, let's just have a little number line here. 0, 19. 19 is not included. So in my open math, you're going to have a circle, all right? And then your arrow is going to go to the left because it's less than. And in set builder notation, I'm sorry, in interval notation, you're going to have parenthesis, negative infinity to 19, and 19 will have a parenthesis because it is not included. All right, let's look at B. Please make sure you're taking notes. Please make sure that you're writing down any questions you have as we're going along. So as you're following along, any questions you have, please come to me and let's work through those. So 6 is greater than or equal to x minus 1. Again, I'm going to solve for x. So I'm just going to add 1 to both sides. So 7 is greater than or equal to x. I like it to flip it the other way. It always makes more sense to me to say x is less than or equal to 7. Again, with a number line, 0, there's a 7. The 7 would get a dot if you're doing this in my open math. And it's less than, so the arrow goes to the left. And interval notation, you're going to have negative infinity to 7, and 7 gets a bracket. Let's finish up with C. X plus 7 is greater than 9. Subtract 7 from both sides, and x is greater than 2. All right, number line. There's 0, there's 2. It is not included because there's no equal sign here, so it just gets a circle, but x is greater than, so it's heading off to the right. And for our interval notation, we're just having an open parenthesis for 2 because it's not included, and then following up with a positive infinity with another parenthesis. Okay. All right, what's next? Demonstrating the multiplication property. Okay, this one gets fun. This is where a little, be very careful here, and I need to watch my language to make sure that I'm saying the right things for you as far as explaining sign changes. It's actually, we'll get there. So let's start with A. 3x less than 6. I'm just going to solve for x, so divide both sides by 3. Nothing exciting here. X is less than 2. On a number line, let's see, that's 0, there's 2. 2 is not included because there's no equal sign, and x is less than, so it goes off to the left. Interval notation, it's negative infinity, comma, 2, parenthesis. And that's it. The next one's when the fun starts happening. So for B, negative 2x minus 1 greater than or equal to 5, solving for x. So I'm just going to add 1 to both sides. So I get negative 2x is greater than or equal to 6. Now, anytime you multiply through or you divide through by a negative number, your inequality sign changes. So dividing by negative 2, what you do to one side, you do to the other. And when you do that, you get x is less than or equal to negative 3. Okay? So the inequality sign changes when you multiply through the entire equation or divide through the entire equation by a negative number. All right. On the number line, that just looks like there's 0, there's negative 3. There's going to be a dot, not a circle, but a dot because it has the equal sign. And then x is less than, so it's going off to the left towards negative infinity. So our interval notation is going to be negative infinity, comma, negative 3. And it's included, so it gets a bracket. All right, let's finish up with C. 5 minus x is greater than 10. Solving for x, we're just going to subtract 5 from both sides. And I get negative x is greater than 5. All right, so again, I'm going to have to either multiply through or divide through by a negative. I would just think of it as dividing. It's the same thing. And I get x is less than, you've got to flip that inequality sign, negative 5. Again, with my number line, I've got 0, negative 5. Negative 5 gets a circle because there's no equal sign, and x is less than, so it's going off to the left. Interval notation, open parenthesis, negative infinity, comma, negative 5, and close out with a parenthesis. And that's it. All right. Example 5. Solving an inequality algebraically. All right. So, well, we need x's on one side and constants on the other. I'm going to go ahead and move the 10 over, so negative 10x. And I'm going to move the 13 to the other side. All right, so I get negative 17x. And all I'm doing is adding, subtracting there, so no sign changes here. And then negative 4 minus 13 is negative 17. Okay. Now we're going to divide through by negative 17 to isolate x. And we get x is less than or equal to 1. Because we divided by a negative, the interval sign, our inequality sign flipped. Okay. So this looks like we've got 0, we've got 1. It's got the equal sign, so it gets a dot. And then x is less than, so it's going off to the left. All right, so negative infinity to 1 and bracket because it's included. All right, solve the inequality and write the answer in interval notation. All right, so I'm going to start off, I'm just going to rewrite this just to make it a little bit easier. Easier to see. Greater than or equal to negative 5/8. Plus 2/3 x. So the first thing I'm going to do is go through and get rid of the fractions, since I know you all love them dearly. So I have to find what would be common to where everyone would have the same number. 4 needs to be involved. So if you think of this as primes, I know some of you think of it in prime numbers. The 4 gives us a 2 times 2, so we have to have that. The 8 gives us 2 times 2 times 2, so now we need a third 2. And then finally we have a 3. So this is going to be our guy right here. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So I'm going to multiply every stinking one of these terms by 24. So when I multiply through, 24 divided by 4 is 6. So I have negative 3x times 6, because this reduced to 6 and 1. Greater than or equal to 24 divided by 8 is 3. So there's 3 plus, and then we have 24 divided by 3 is 8. So 2x times 8. All right, so we've got negative 3x times 6 is negative 18x, greater than or equal to negative 15. And then 2 times 8 is 16x. Let's get our x's on one side. So I'm going to shift that 16x to the other. I get negative 34x is greater than or equal to negative 15. All right. And then solving for x, we're just going to divide both sides by negative 34. Remember, when you divide through or multiply through by a negative, the inequality sign changes. It flips. And I don't think those have anything in common that I can reduce that by. All right. Is there anything I was supposed? No, I think we're good. I think we're good. So the next thing we're going to look at here is, what does this look like in interval notation? So here's 0. Here's 15 over 34. Okay. You can put it in decimal form too. It doesn't matter to me either way. And then it's x is less than or equal to. So we need a dot if you're doing my open math. And then it's less than, so it's going off to the left. Interval notation, we're going to have open parenthesis negative infinity, comma 15 divided by 34. And because it is equal to, it is getting a bracket. Again, please make sure that you're writing down any questions that you have. I'm going to take a break from my mouth real quick. Your ears probably. Okay, let's move to example 7. We've got solving a compound inequality. There's a couple ways you can do this. I'm going to show you the way that I suggest so that there's fewer mistakes. But I'm going to show you the other way just so that you know that it can be done that way as well. All right. So the first thing I'm going to do, less issues I see is if you actually take them and separate them, where the common one is this one here. So I'm going to have 3 less than or equal to 2x plus 2. 3 less than or equal to 2x plus 2. And then I'm going to have 2x plus 2 is less than 6. Solve for x in both cases. So I'm going to leave the 2x here, move the 2 over. 1 is less than or equal to 2x. Solving for x, divide both sides by 2, and x is greater than or equal to 1/2. I'm just going to flip that around. There we go. All right, the other one, subtract 2 from both sides, and I get 2x is less than 4, divide both sides by 2, and x is less than 2. Okay, cool. Let's go ahead and write that in interval notation. So let's do our little number line here. We've got 0, 1/2, and 2. Let's just say 1's right there. So at the 1/2, it's equal to, so it gets a dot. And x is greater than, so it's heading off in this direction. The other one is 2, and it is not included, so it just gets a circle. And x is less than, so it is heading off in this direction. So this is going to come together as a bar, okay, to where 1/2 is included, and then it's everything greater than 1/2 with the exception of 2, and it stops, okay, up to 2. In interval notation, that's just bar facing the direction the arrow is going, 1/2, comma, 2, parenthesis, because it is not included. All right. If you don't want to learn the other way, you can fast forward until you get to example 8. So what does this look like in the other format? 3 less than or equal to 2x plus 2 less than 6. Just solve for x. So subtracting 2 from all, and which you have to do it to all 3 sides, and you get 1 is less than or equal to 2x is less than 4. Okay, and then divide through by 2, and you get 1/2 less than or equal to x less than 2. Same thing we just got. Okay. Drifting out. Example 8. Solving a compound inequality with a variable in all 3 parts. And this is supposed to be a 10 right here. Solve the compound inequality with variables in all 3 parts. So we've got 3 plus x greater than 7x minus 2 is greater than 5x minus 10. Ooh, yeah, I'm separating these bad boys. So 3 plus x is greater than 7x minus 2, and then 7x minus 2 is greater than 5x minus 10. Solving for x. I'm going to just bring my 7x over, so negative 7x. And I'm going to bring my 3 over here. So I get negative 6x is greater than negative 5. Divide both sides by negative 6 to solve for x. And we've got to flip our inequality. So x is less than 5/6. All right, let's do the other one. I'm going to bring 5x over here. And I'm going to bring the 2 onto the other side. So I get 2x is greater than negative 8. Divide both sides by 2. And x is greater than negative 4. All right, what does that look like? Let's put negative 4 here. And 0 and 1. So right there's 5/6. So 5/6 does not get a dot, it gets a circle. And x is less than, so it's heading off in this direction. Now at negative 4, it's not included either, and it is heading off to the right because x is greater than. So it too is having a barbell. So we've got parenthesis because negative 4 is not included, comma, 5/6, another parenthesis because it is not included. Okay. All right, almost done. I'm going to take another break real quick. Okay, last break. So you're going to need this next section up here. That's why I made sure that you had that. If your absolute value terms are less than your constant, this is equivalent to negative of that constant is less than the absolute value part is less than k, less than the constant itself. And then if there's a greater than sign instead, you're going to have that the x is less than the negative version of your constant, or the x is greater than your constant and even in the positive form. All right, so I'm going to show you how to do this. Determining a number within a prescribed distance. It says describe all the values x within a distance of 4 from the number 5. So no more than 4. So it can be less than 4 from the number 5. Okay, so absolute value of x minus 5 is less than or equal to 4. Okay, so if we have a less than, let's use this up here now. Less than means we're going to have -4 less than x minus 5 less than 4. So it's -4 less than, this is less than or equal though, because it has the equal sign. X minus 5 is less than or equal to the 4. Okay, because the absolute value of the binomial that we have is less than the constant. All right, so let's solve that. This would be an easy one just to leave it as it is and work from this, but I'm going to go ahead and separate them for you. -4 less than or equal to x minus 5, and x minus 5 is less than or equal to 4. Solving for x, I'm going to add 5 to both sides, and I get 1 is less than or equal to x. I'm just going to flip that around. All right, and then this one, we're going to add 5 to both sides. We get x is less than or equal to 9. Okay, what's next? Well, we can have a number line to, check that out. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where we started, is right here. 1 is included and x is greater than. 9 is included and x is less than. So that takes care of within 4 from 5, within a distance of 4 from the number 5. All right, putting that in interval notation, that's just bracket because 1's included, 1 comma 9, and bracket for 9 because it 2 is included. Okay. All right, let's go to 10. I'm going to need more space than this, however. Okay. So solving an absolute value inequality. Now this one's a less than again as well. So we have to do the same thing. So it's going to be -3 less than or equal to x minus 1. And x minus 1 is less than or equal to 3. Okay. Solving for x, adding 1 to both sides, we get -2 less than or equal to x. Just going to flip those around real quick for me. X is greater than or equal to -2. And then over here, adding 1 to both sides, x is less than or equal to 4. All right, what does that look like? But -2, 0, 4. -2 is included, so it gets a dot, and x is greater than, so it's going off in this direction. 4 is included as well, so it too gets a dot, and x is less than, so it's heading off in this direction, and we've got another barbell. All right, let's put this in interval notation. -2 is included, so it's a bracket, -2, comma, 4, and 4, 2 is included. And that is it for that one. One more. All right. Okay. Let's make sure this is all even. So given this equation, y equal -1/2, absolute value of 4x minus 5 plus 3, determine the x values for which the y values are negative. So they want y to be negative numbers. So we need to find out at what point is y 0, because then we can go from there. So the first thing I'm going to do is we need all of this to be less than 0. So -1/2, 4x minus 5 plus 3 has to be less than 0. Okay. Well, let's start by moving 3 to the other side. Okay. And we get -1/2. 4x minus 5 is less than -3. Okay. Well, let's get rid of our fraction here, because I know y'all don't really like to deal with those. So I'm going to just multiply times the negative reciprocal here. Since we have -1/2, I can multiply by -2. Negative and negative is going to give me a positive. 2 divided by 2 is going to give me 1. So that leaves me with just 4x minus 5. And then multiplying this side by -2, I get 6. All right, it's at this point I need to say, okay, the absolute value of 4x minus 5, I need to set it equal to 6. And the other thing I need to do is take 4x minus 5 and set it equal to the -6. Okay. So, and why am I doing that? Less than. This is less than 6. So I have to use the fact that the absolute value portion is less than the constant. That's what tells me I need to do this. So 4x minus 5, I'm going to set that equal to 6. Minus 5 equal to -6. All right, adding 5 to both sides. 4x is equal to 11. Divide both sides by 4. And x equals 11/4. Add 5 to both sides. And I get 4x is equal to -1. Divide both sides by 4. X equals -1/4. What does this look like on the number line? And we'll just say, all right. So the 11/4 is hitting there. That just tells me where, well, first of all, this is an absolute value graph. So I already know it's going to be, you know, in more of a, it's going to be a V-shaped. Okay. Please feel free to put this into your calculator. Honestly, I prefer desmos.com to access that. It's DESMOS.com. Man, it's just brilliant because you can just zoom in so easily with just a mouse or your finger and find out which points are where. But this is telling us what our x-intercepts are on our Cartesian coordinate system. Okay, because this is my y. So I know that, well, first of all, this is +3. So 1, it's going to be bigger than that. 1, 2, 3 is where I'm going to be crossing, but it's going to come through, not touching. We're going to have like a faux, I'm going to try to do a dotted line. If you put this in Desmos, you will see that it's going to look more like this. I put dotted here because it's not included. Okay. I'm also going to put circles around these because they are not included either. The question up here is to determine the x values for which the y values are negative. So the y values aren't negative until you get below the x-axis. So this keeps coming off in this direction, and this one keeps coming off. Oh gosh, sorry y'all. Yeah, it's not going to get any better. In that direction. Pretend that's straight. None of this is included, nor is anything that's touching the x-axis. It's the lines below it that are included. All right, but we need to know what that's referencing on the x-axis. And in this case, it's saying, well, negative infinity is going to be included over here. It's going to keep going and going and going. So negative infinity, oh my God, I need to just, comma, -1/4. -1/4 is not included. Okay. Or on this side, we've got 11/4 parenthesis because it is not included either. And it's going off towards positive infinity. But if that would be just put together. So our answer would be infinity, -1/4, 11/4, positive infinity. Okay. And it's just the parts of the graph below the x-axis to ensure that your y values are negative. Okay. Again, write down your questions. Come see me if you have any questions, shoot me an email. Talk to you soon.